This lesson is about calculating the area of a triangle when we don't know the height of that triangle. If you recall, when we've done used our law of sines and cosines to solve a triangle, we haven't been given any information about the height of that triangle. So it's nice and time efficient if we could actually find the area of a triangle without having to go through the work of finding the height of that triangle. So much like I did when we proved the law of sines, I have drawn two triangles. One is acute and one is obtuse. And so I'm going to, and I've drawn the height in to the triangle. So again, I am going to use the sine of angle A is equal to, here's our right triangle here with the height drawn in, is equal to the opposite side of A over the hypotenuse, which is C. So when I solve this for H, which is our height of our triangle in this case, a little bit of a misnomer in that H is not the hypotenuse, so don't make that mistake. But H is the height of our triangle, and so when I solve this for H, sorry about that, I get C times the sine of A is equal to H. And that applies in both of our triangles. Here would be angle A in our obtuse triangle. And remember, just by chance, an angle and its supplement, the sine of 180 minus A, which would really be this angle right here, is equal to the sine of just our angle A in our little right triangle, the pink little right triangle there. So this C sine of A equals the height applies in both of these cases. And so now I can just substitute C times the sine of A into my formula for the area. So if area equals 1/2 the base times the height, and in this case remember that B actually is side B because we have angle B right here, and so our base is this entire side here, so that is our B. So area equals 1/2 of side B times C times the sine of angle A. So this is our formula using sine to find the area of a triangle, and I should write the word area because that can be deceiving. Okay, so, and of course I could flip this triangle around in any direction and prove this for the other angle measures. So I'm just going to, for the sake of time, I'm going to write area is also equal to 1/2 A times B times the sine of angle C, if that happened to be the configuration that you had of your triangle, or area is equal to 1/2 A times C times the sine of B. And much like how we've tried to make sense of these formulas in the past, if we're talking about, in this first example right here, if we're talking about angle A, then you multiply the sine of angle A times the side lengths, 1/2 of the side lengths of the other two sides. So in case number 2, we were using angle C. It's 1/2 times the side lengths of the other two sides times the sine of angle C. So you can see that there also is a pattern going on there. So we could say that the area of a triangle, I keep forgetting to hit my pencil, sorry about that, area of a triangle is 1/2 the product of the lengths of two sides and the sine of the angle between those two sides. Okay, so we'll do an example. So here we have triangle DEF with side DE being 9 feet, EF being 12 feet, and the angle between them being 127 degrees. So we know that the area then of triangle DEF, area is equal to 1/2. We're given angle E, so when we're just talk about the pattern, we would say 1/2 side D times side F, and this will be times the sine of angle E. Okay, so let's just plug and chug, as they say. Area equals 1/2 9 times 12 times the sine of 127 degrees. So when you put that into your calculator, the area will equal 54, that's 1/2 times 9 times 12, times the sine of 127 degrees is 0.7986. Okay, obviously I'm just going to write the abbreviated version of the sine of the angle, but I'm holding it into my calculator times 54. And that means that the area of this triangle is equal to 43.126 feet squared. And that's the area of that triangle. So it's kind of handy to be able to use the sine of an angle. If we have side angle side in one way, shape, or form, you might have to come up with an angle using the tools that you have. But once we already have this information, we can easily find the area of that triangular region. Okay, another method of finding the area of a triangle is called Heron's formula. And Heron was a Greek mathematician and engineer that lived all the way back in AD 10 through 70. So he came up with this formula where he discovered that you could calculate a semi-perimeter, meaning half of a perimeter of a triangle, is equal to S, or S is equal to, the semi-perimeter is equal to 1/2 the sum of the sides of the triangle. So then he also discovered that the area of a triangle could be calculated by taking the square root of S times the quantity S minus side A times S minus side B times S minus side C, and that would give us an area of a triangle. So we have an example problem here that says as the crow flies, which means like you could draw a straight or fly a straight line from, in this case, Chicago to St. Louis. Whoops, sorry, here I go again, is 262 miles. And then if we flew from St. Louis to New Orleans, let's call this St. Louis, we're going to call this Chicago, and this is New Orleans. This would be 599 miles, and then to fly from New Orleans all the way back to Chicago would be 834 miles. Sorry, the typing is cut off there a little bit. But Heron's formula, so the question is, what is the area of this triangular region? So if we calculate our semi-perimeter, that's going to be 1/2 of all the sides added together. So 262 plus 599 plus 834. And that will give us that S is equal to 847.5 miles. So that would be a linear type of a dimension. Okay, so what I recommend to you to do is, because this is using the S over and over and over again, go ahead and store that in alpha S. So then when you go to do the calculation, you don't have to keep typing in 847. It's kind of annoying. So when I write my work for the area of this triangle, I'm just going to write an S. So it's not as cumbersome looking, and that will mean my stored S that is in my calculator right there. Okay, so S is equal to 847.5 miles. Okay, so then our area, we're ready to go on this. Area is equal to the square root of S times S minus 262. That's our S minus A, so to speak. And then S minus 599. And then times S minus 834. Sorry. Just like in school with the smartboard, I run out of room. Okay, so that will give us, so I'm on my calculator, I'm actually, typing alpha S. I typed in the big, the square root of, and it'll give you a parenthesis. And so you're just going to, if you've stored it in S, you can go alpha S, and that'll be your 847. And then you don't need the multiplication sign, just use parentheses as your multiplication. So you can type it in your calculator just like this, exactly like that, and it'll work. So that calculates out to be an area of 40,800.3 miles squared, or square miles. So that's it. So Heron's formula and using the sine of one of the angles in a triangle make it easy for us to be able to calculate an area of a triangle if we need to and we don't know the height. So I will answer any questions that you have in class. You should be able to try your homework that's listed on your assignment sheet or on Teachers I/O at this point. Thanks for listening.